Alright, welcome to my YouTube channel. Thank you so much. So in this video I'm going to introduce you to matrices. I've received comments and also messages. You've been asking me that I produce a video on matrices, and I am delighted to produce this video for you. So let's get started. What are we going to look at in this video? Well, we are going to learn matrices. So this will be an introduction to matrices, but then what are we going to look at under matrices? We're going to look at a 2 by 2 matrix or matrices. Now under that one, we are going to look at the addition, subtraction, multiplication of 2 by 2 matrices. After which we also look at how we can find the determinant and the inverse of matrices. That is 2 by 2. Then we'll move on to 3 by 3 matrices. Now under 3 by 3 matrices, we are also going to look at the addition, subtraction and multiplication of 3 by 3 matrices, and also how we can find the determinant and the inverse of 3 by 3 matrices. So right away, let's start by defining what a matrix is. Now a matrix is simply the arrangement of symbols or expressions or numbers in terms of rows and columns. Now matrices are named based on the type or on the number of rows and columns they have, which is called the dimension of a matrix. So dimensions of different matrices tells us the type of matrix it is. For example, if we have a matrix, an n times m, which is n by m matrix, such a matrix implies that it has n number of rows and m number of columns. So a matrix which is simply written in row form like this one here, as you can see this one, it has just a moment. When you look at this matrix, it is just written in form of a row, right? 1 2, so with one row. Okay, now a matrix written in this form is called a row vector, okay, and not a row matrix but a row vector. Okay, so that's the name. When you look at this matrix, it is just written in a column form, right? That's 4 3. So this matrix, which is just written in form of a column, is also just called a column vector. Good. Now let's look at this one. When you look at this matrix, it has n number of rows and m number of columns. Now we can count the number of rows and the columns. The first one on top, which is 0 2, gives us the first row, right? And then the second one, 2 and 4, gives us the second row of this matrix, right? Good. So we can notice that it has 2 rows, right? Then columns, it has 1 2. So again, this matrix has 2 number of rows, 2 number of columns. So what will be its dimension? Well, its dimension will be 2 by 2 matrix. And apart from it being a 2 by 2 matrix, it is also a square matrix. Why do we say it is a square matrix? Well, when you look at the name itself, a square shape has all the sides equal, right? Now the same applies to this matrix. When you look at it, it has equal number of rows, okay? The number of rows are equal to the number of columns that it has. So it has 2 number of rows, 2 number of columns, and that makes it a square matrix. Good. Now let's look at the third one. And when you look at this matrix, look at its elements. So it has all the elements zeros. What is the name of this matrix? So how can you call it? Well, this matrix is a zero matrix. But then apart from it being a zero matrix, because all the elements it has are zeros, it is a 2 by 2 matrix. It has 2 number of rows and 2 number of columns. Now that suggests it to be a square matrix. Good. Now let's go to the third one. We have this matrix here. It has 2 rows, right? We have the first row, this one, 2 4 5, and the second one 4 8 7, right? Right. Now how many number of columns does it have? So we have 2, 4, 4, 8, and 4, 7. So we have 1, 2, and 3. So we have 2 rows and 3 columns, right? So this matrix, the dimension will just be 2 by 3 matrix, telling us that this matrix has 2 number of rows and 3 columns. Good. Let's proceed and look at the other one. This one, you can count how many rows it has. It has 1, 2, 3, right? So we have 3 rows and only 2 columns. So the dimension of this matrix is 3 by 2 matrix. It's not a square matrix because the number of rows are not equal to the number of columns that it has. Let's proceed and look at the other one. So look at this one. Now this matrix has 3 rows, right? Good. And then 3 columns. So this matrix having equal number of rows to columns is called a 3 by 3 matrix, and it is a square matrix because the number of rows are equal to the number of columns it has. Good. So let's proceed and look at something new here. Let me now introduce you to a transpose of a matrix. Now, what is a transpose of a matrix? So this is just an operator that switches the row and column elements of a matrix by producing another matrix, which is often denoted by A transpose, which is A superscript T, a capital letter. Now, it's not always that it's going to have A with a superscript T. A can't always be the letter to be used. This matrix can be denoted using Q superscript T, W superscript T. So that tells you this is a transpose of a matrix. We can look at one example here. If we have a matrix Q, which is given to be 1, 2, 3, 4, so the dimension of this matrix is 2 by 2, right? Because it has 2 number of rows, right? And 2 columns, which makes it to be a square matrix, right? From the previous page. Good. Now, finding the transpose of this matrix, in line with the definition, is just an operator which is switching the rows to columns and columns to rows. So we can see that the transpose of this matrix Q we have is going to tend to be 1, 2, 3, 4. Now what is happening? You can see the blue row is turned into a blue column, right? Now the red row here, right, is turned into a red column, as you can see there. So this is the transpose of a matrix. Now let's look at the second example. If we have a matrix W, which is given by this matrix, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 with 3 number of rows and 3 number of columns, making it a square matrix again. And then its transpose denoted by W transpose. So you can see, like I said, it's not always that the transpose of a matrix will always be denoted by A superscript T, a capital letter. It can, excuse me, any letter can be used to denote a matrix. So in this case we used Q. Here we have used here we have used W, right? Good. So the transpose of this matrix will just tend to be 1, 4, 7, 2, 5, 8, 3, 6, 9. Those will be the elements of a transpose matrix. So you can compare what was a row in this matrix. It is now a column. What was a row? The second row is now the second column. The third row is now the third column. Good. We can proceed now and look at something interesting. In this video, now the second page, this one, I'm going to talk about the addition and subtraction of a 2 by 2 matrix or matrices. So let's take, for example, we have matrix A, right? And we also have matrix B, and we have matrix C, right? So we want to learn how we can add and subtract these matrices. I want you to pay attention. So suppose we want to add matrix A and B, right? We want to add two matrices, matrix A plus matrix B, okay? What this means is that we're going to substitute matrix A. We substitute with matrix A, which is 1, 2, 0, 1, which is right here, right? Okay, just a moment. Let me just use this. And so we can see we have this matrix. We substitute it right there. And then matrix B is right here. We substitute it also there, right? Then we need to add. So how do we add matrices? Actually, this is a 2 by 2 matrix. How do we add 2 by 2 matrices? Well, this is direct. Add the first element in your first matrix to the first element in your second matrix. So we are going to add 1 plus 3, right? So this is what we are having here, 1 plus 3. Now that will give you 4, right? So this is your answer here. So you do that to all the numbers. The second element of your first matrix to be added to the second element in your second matrix. So again, we have 2 as the second element in the first row of the first matrix, a 2 by 2 matrix. We are going to add that to the second element in the first row of the second matrix, and that will give us, which is just 2 plus 2, which will give us 4, right? So if you do that to the rest of the numbers, you have 0 plus 0, which is right there, you get a 0. You have 1 plus 3, right? Which is 1 plus 3, that gives you 4, right? So this is how you add matrices, 2 by 2 matrices. It's direct. Now let's look at subtraction. Suppose we have we need to subtract 2 matrices. We want to subtract matrix C, right? We have matrix C minus matrix A. So we are subtracting matrix A from matrix C. So we have our matrix C is right here, right? So it's 0, 2, 4, 1. So you get that matrix, substitute it right here. I'm sure you can see it. And then you also get matrix A, which is right here, and substitute it, which is here. So now let's start subtracting. Again, also subtraction of 2 by 2 matrices is direct, just like addition. So you subtract the first element in the second matrix, right? The first element in the first row of the second matrix from the first element, okay, in the first row of the first matrix. So what I mean is, like this one, we have the first element in the first matrix, and the second matrix we have the first element, which is 1. So we are going to subtract, which is 0 minus 1. This is what we have, and that will give us negative 1. And then we go to the second element and the second element in both matrices. So we have 2 minus 2, which is right here, and which will give us a 0. Again, we have 4, the first element in the first matrix. We also have 0, the first element in the second matrix, but in the second row, and also in the first matrix, it is in the second row. So 4 minus 0, we have 4 minus 0 right there, which is 4. Okay, so if you do that, what you are going to get is negative 1, 0, 4, 0 as the sum of two, as the difference of these two matrices that we've been given. All right. So just take your time. You can even pause the video and confirm this. Let's look at multiplication of 2 by 2 matrices. So suppose again we have 3 matrices, matrix A, matrix B, and matrix C. Now multiplying two matrices, matrix A and matrix B, actually we do so by following what we call row by column. Okay, let me just alright, so we can just use the same one. So when you look at this, we have our first row and our first column in the two matrices. So we are multiplying matrix A and matrix C, right, as you can see here. Okay, so we substitute matrix A, which is 1 2 0 1, it's right here. Then we have matrix B, which is a matrix C, which is 0 2 4 1, which is right here again. Okay, now we need to multiply. Now how do we multiply matrices? We multiply matrices row by column. So in the first matrix, we have our first row, which is this one, right, 1 2, and then we have our first column in the second matrix, which is 0 and 4, right, this one. So we have to multiply them. Now how do we multiply? The first row by the second column. So what we do is you multiply the first element in your first row of your first matrix by the first element in the first row of your second matrix, right, which we can see here how that is being done. So we have 1 times 0, right? Now you add with the product that you get when you multiply now the second element in the first row of your first matrix, right, by the second element in the first column of your second matrix, which is 4. So you multiply 1 times 0, 2 times 4. Now if you look at this one, which is 2 times 4, is what we have here again. So you add the two products. Okay, when you multiply, you have 1 times 0 plus 2 times 4. Okay, so we are done with the first row and the first column. Now you can also do the same to the second column using the first row, okay, in the first matrix that you have. Okay, so let me just again do that. In the first, so we're still using the first row here, right? Now we go to the second column, which is this one here. So we have 2 1, so we're going to multiply again. Let me just change the color. Okay, so you leave a space. So we have multiplied 1 times 0 and 2 times 4, which was the first row and the first column. Now we are multiplying the first row, so we are maintaining the first row from the first matrix multiplied by the second column from the second matrix. So okay, so what we mean here, I just want to use this color. Okay, so now we use 1 multiplied by 2, right? Again 2 multiplied by 1 here. Okay, now this is what we're having. So that's 1 multiplied by 2 plus here. Okay, we add the product 2 times 1. Okay, I'm sure you're able to see that pattern, how we are doing it, right? So if you do that to the rest of the elements we have, so the first row, just this row here, okay, this one gives us what we are getting when we multiply the first row and both columns in the second matrix. Now you need to move on to the second row here. Okay, so the second row are going to multiply again 0 times just so again you are going to multiply. It's not 0. Let me just erase this one. Okay, so what let me just highlight here. So we are going to multiply now. We are going to the second row. So 0 multiplied by, so it's now the second row and the first column, okay, again the second row and the second column. So we have 0 multiplied by 0 plus 1 multiplied by 4. Again 0 multiplied by 2 plus 1 multiplied by 1. I mean 0 multiplied by 2, good, and then 1 multiplied by 1. You can see that one here. That's why I've, in case you get confused there, that's why I have written this stage so that you can follow. Okay, so this is what I'm talking about here. So you can compare the arrangement that I've put here with the rows and the columns in both matrices that we are multiplying, and then you can see the pattern that we are using. All right, so this is what you are getting. Let us also look at this other one. When you have been given a matrix, okay, look at this one. We have we want to multiply 2, okay, by the product of matrix A and C. Now the product of these two matrices AC is what we are from finding here, right? And the answer we have found is right here. Okay, so the answer we have found for the product matrix A and C is this one, right? Now this matrix, we want to multiply it with a number, right? A whole number, which is 2 here, as you can see. So I'm multiplying 2 by matrix AC. So there is no need of you to start multiplying again, okay, because you have this matrix, which is AC, this one, right? So just get that matrix AC, which is this one, right, and multiply it by these 2 here. So we are going to multiply throughout. You are going to multiply 2 times 8, again the same 2 times 4, again 2 times 4 right there, again 2 times 1 right there. When you do that, you are going to get matrix this one. You have 16, 8, 8 and 2 as your matrix. Okay, you can pause the video again even here and try to write this down. Try to multiply following the same procedure. Just follow the same steps, multiply row by column, and you are going to do the right thing there. Okay, now let us look at the determinant of a 2 by 2 matrix or matrices. So let's start by defining what a determinant is. So a determinant is just the difference of the product of elements in the major diagonal, right, and minor diagonal. Now you can see they have used the letters. Now to explain what these letters mean, okay, A times D, the difference, and then in the minor diagonal of B times C. What that means is that the determinant of a matrix, any matrix, a 2 by 2 matrix, you can be given to find its determinant. So you find the difference in the major diagonal, the product of a major diagonal, which is A times D. As you can see, we have A times D minus, right, the minor diagonal, which is B times C, right? Okay, so that's what we have. Let us look at an example to see how we find the determinant of a matrix, which is just the difference in the major diagonal, okay, the difference between the product in the major diagonal and the product in the minor diagonal, which means the elements in both diagonals. So if we have matrix Q given by 3, 4, 5, 2, right, as you can see here, right, to find the determinant, we apply AD minus BC. So the difference in the major diagonal and minor diagonal. So the difference in their elements, we find the products, then we find the difference in the products of the elements in the major diagonal, right, which is this one, and the minor diagonal. So to do that, we have 3 times 2 right here minus the product in the minor diagonal, which is 5 times 4 right here, which will give you 6 this side minus 20, and that will give you negative 14. So negative 14 is the difference in the product in the major diagonal, right, and minor diagonal. So the difference between the products in the major diagonal, okay, the products of the elements in the major diagonal and the minor diagonal of your matrix is negative 14. Let's hope you're able to get the concept. To help you understand, let's look at this other matrix. We have matrix M, which is equal to 10, 3, 0, 3. Again, we apply the formula, which is determinant of matrix Q. Is we have the product in the major diagonal elements minus the product of the elements in the minor diagonal. So that means we have 10 multiplied by 3 minus 3 multiplied by 0, right? And that will give us 30. So that is the determinant of matrix M. Alright, again, you can pause the video here and try to go through, just apply the concept here, and you are going to find the correct answer. Okay, now let us move on and look at the inverse of a 2 by 2 matrix. Okay, now let's start by defining what an inverse is. So the inverse of a 2 by 2 matrix, we are told here, according to the definition, this is just the matrix which, when multiplies with the given matrix, gives the multiplicative identity. If you want to know about a multiplicative identity, again, you can just leave a comment there. I can give some more examples of how that operates as 1. Okay, just like 1, when you multiply 1 with any number, you still get the same number. Now that is a type of matrix we get, which is the inverse. Now the inverse of a matrix is usually denoted by, it can be A, superscript -1, Q. This simply means any letter can be used to represent the matrix, but always that matrix is going to have a superscript -1, which simply means the inverse of that matrix, that you can multiply with another matrix to get the multiplicative identity. Now let's get that into detail. So if we have a matrix, okay, to find the inverse of our matrix A, which is A, B, C, D, right, is given by 1 over the determinant of matrix A, which means first we need to get the determinant of the matrix A. To find the inverse of a 2 by 2 matrix, first you need to find the determinant of a matrix. Again, you need to find the adjoint of a matrix, this one, then you multiply, right? Let's look at an example to learn how to find the inverse of a matrix, which is a 2 by 2 matrix. For example, find the inverse of a matrix, right? That's the inverse of a matrix. That's a matrix of Q. Now Q is given by 3, 4, 5, 2, right? Now to find the inverse, first we need to get the determinant of this matrix, which is a 2 by 2 matrix, matrix Q. So how do we find the determinant? So we apply the formula here, and so we have the difference, right, in the major diagonal products and the minor diagonal there. Okay, we get the products in the major diagonal, the product, that is 3 times 2. Okay, and in the minor diagonal we have 4 times 5, and then we subtract now the minor diagonal from the major diagonal, and that will give us 6 minus 20, and we have negative 14. Okay, just like we got the same answer in the previous explanation there about determinants. So we have the determinant for this matrix Q, right? Now how do we get the adjoint of a matrix? So to get the adjoint of a matrix, what you need to do, you need to swap the elements in the major diagonal, right, as you can see. So 3 and 2, you swap. We can see 3 and 2, they have swapped the positions, okay? And then in the minor diagonal, this one, 5 and 4, you multiply that with the standard signs, okay? Okay, so the standard sign for a 2 by 2 matrix, we have the first number, okay, the first element of a 2 by 2 matrix corresponds to a positive, right? Then the second element corresponds to a negative. You can just refer to the standard sign here, okay, of a 2 by 2 matrix. So in short, we need to swap the major diagonal elements, again multiply the elements here that we get by the sign matrix, the standard sign matrix here. So that's why we have multiplied minor diagonal elements by negatives, as you can see, because they are positive initially, right? That's why we are getting them to be negative. So if any of these two numbers in the minor diagonal, the elements had the negative, it would have maintained a positive sign. All right, so let's proceed now and look at again the inverse of a 2 by 2 matrix. Remember from the previous page, this one, we have already found the determinant. We want to find the inverse. We have found the determinant to be negative 14, and we want to see how we are going to apply this formula here. Now we are looking for the adjoint of a matrix, which we have found by swapping the elements in the major diagonal and multiplying the elements in the minor diagonal by negative signs. So we have the adjoint of a matrix, it's this one, right? Now we need to apply the formula for the inverse. So the inverse of a matrix, a 2 by 2 matrix, is given by 1 over the determinant of that matrix multiplied by the adjoint of that matrix. So what this simply means is that we need to substitute. So we have 1 over negative 14, right? Now negative 14, so I've just indicated the negative to the denominator, negative 14, so that you remember to say negative 14 is just the determinant. Okay, this is just the determinant that we got. Okay, that's negative 14. You need to multiply a negative to the numerator, of course. Okay, now we need to multiply this by the adjoint matrix. Look at this, is the adjoint matrix we have found, and you just need to substitute it there. So we are multiplying, right? So if you do that, you are going to get the inverse of this matrix will be, so you multiply negative 1 over 14 times 2, that will give you negative 1 over 7, right? So you still need just to multiply that there, okay, and not here. So make sure the negative sign is with the numerator and not the denominator. Okay, again, when you multiply 1 over negative 14 multiplied by negative 4, that will give you positive 2 over 7. Again, when you multiply 1 over negative 14 by negative 5, that will give you negative 5 over 14. Again, here someone sent me a message asking how to multiply a fraction by a whole number. So we have negative 1 over 14, right? Let me just demonstrate this. For example, we are multiplying this by negative 4, right? So what this means is that you multiply, what this means is that you are multiplying negative 1 times, right, times negative 4. This is how you can simply take it if you get confused, over 14, right? So multiply what you have as your numerator. You have negative 1 times negative 4. Now this will give you just positive 4, right, over 14, right? So that is what you have. Now this can be simplified by dividing both the numerator and the denominator by 2, and that will give you 2 over 7, right? And this is what we had put there. Okay, Good. So this is the inverse that you are going to get, and this is how you find the inverse of a 2 by 2 matrix. So first, start by finding the determinant of that matrix. Okay, find the determinant of that matrix. When you find the determinant of that matrix, then go on to find the adjoint of the matrix by swapping the elements in the major diagonal, right? And then the elements in the minor diagonal, we multiply them by negative signs, right? Good. So thank you so much for watching this video. Now in the next video, we are going to learn 3 by 3 matrices.